For lesson 4, we learned 2 other shortcuts for proving triangles congruent. If we know angle side angle, 2 pairs of angles in the included side, or angle angle side, 2 pairs of angles in the corresponding non-included side, we can say that we have congruent triangles. So we're going to learn about those shortcuts, learn what they are saying, learn what they're not saying, and attempt to use those shortcuts to prove that triangles are congruent. So angle side angle. If 2 angles in the included side of one triangle, all right, so 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then those 2 triangles are congruent. So again, we're using that language of included, included, included. Last time we talked about an included angle, now we're talking about an included side. So how do we know what the included angle is? Angle M, angle N, included side MN. Angle S, angle T, included side ST. All right, so the names of the angles tell us what the name of the included segment is. So using angle side angle, which 2 triangles are congruent by using angle side angle? Well, here we can see that we have 2 angles in an included side marked. I have got 2 angles in a non-included side marked. I've got 2 angles in the included side marked. So the first triangle and the third triangle are congruent. We would write the congruent statement. We can call this triangle DOG is congruent to triangle. The D corresponds with X, the O corresponds with Y, and the G corresponds with Z. All right? And so we can show that those triangles are congruent using angle side angle. Let's do a proof. Now this should look familiar. This is an item that we did on our last, or 2 tests ago, where we had some parallel lines and stuff like that. So I want for us to see that these lines are parallel. These lines are also marked congruent, or these line segments, and then this angle is marked congruent to that angle. So if I want to use side angle side, I would need to show that these are congruent. If I want to use angle side angle, I would need to know that these angles are congruent. Well, that's a great question. Are these angles congruent to each other so that I can use ASA? That's the goal. So they are congruent, right? We're going to make sure that we know that they are. So we are given that E is congruent to D, that's given information. We know that AE is congruent to BD, that's given. And we know that AE is parallel to BD, that's given information. So 3 of our statements are freebies. They're free points. There's one moment here where we have to think, and that is understanding that this angle is congruent to that angle because these are parallel lines cut by a transversal. And so those are called corresponding angles. So we will use the corresponding angles theorem to say that the angle at A is congruent to the angle at B. I have to name angle B using 3 letters, DBC or CBD. The angle at A, I could name it with 1 letter, or I could call it EAB or BAE. And therefore the triangles are congruent by angle side angle. All right, we've got pair of congruent angles, pair of congruent sides, pair of congruent angles. Angle, side, angle. 2 pairs of angles in the included side. All right, angle side is maybe the harder one because it requires us to really read and understand what we're talking about. It's not just 2 angles and then any side. It's if 2 angles and a non-included side of one triangle, so angle 1, angle 2, and then the side that comes next, so angle, angle, and then side, they have to be congruent to the corresponding non-included side. So 2 angles and the corresponding, so angle 1, angle 2, and then the third non-included side, all right? So angle, angle, side. Angle, angle, and then side. It's not angle, angle, skip a side, and then go to the next side, right? We have to make sure that WV is congruent to ZY, not WV congruent to XZ, all right? Because otherwise those would not be congruent triangles. So we're going to use angle, angle, side in this proof. I hope that you're enjoying seeing all these proofs done for you so that you can replicate them when you're in class. We are learning here that PR bisects angle SRQ. So this is angle SRQ. That's this angle right here. And they're saying that PR bisects that angle. So if PR, this segment right here, cuts that angle in half, it means that this one is congruent to that one. Those are congruent angles. You're also told that angle S is congruent to angle Q. And we know that we have PR congruent to itself by the reflexive property. That's a freebie. All right, so you're given, and then freebie. So S is congruent to Q, the angle S congruent to angle Q, that's given. PR bisects the big angle SRQ, that's given. And now first freebie, using the definition of bisect, I know that this part, SRP, is congruent to QRP. All right, and that's why we have those angles marked, not the sides drawn in there, the angles marked. All right, and then we have the reflexive property for PR congruent to itself, or RP congruent to RP. Therefore, the triangles are congruent. PRS and PRQ are congruent by angle, angle, then side. Angle, angle, corresponding non-included side. Do we have enough information? Example 4. Is there enough information to prove that these triangles are congruent using our triangle congruence shortcuts? So here we have these sides congruent, but different angles. This one's included, this one's not included. So this cannot be determined. Pair of sides, pair of sides, pair of sides. These triangles are congruent. Here we have pair of angles, and then the corresponding non-included side. So if I went angle 1, angle 2, and then this side, that's not marked, but the corresponding non-included side is. That's amazing. All right, and then here we have 2 angle pairs, and the included sides are congruent, so we know that this is angle, side, angle. So seeing these examples will let you know, hey, I can see that I've got angle, side, angle. Hey, I can see that I've got side, side, side. Or maybe you're not given enough information, and you need to start marking the diagram with things that you can deduce to be true to show that the triangles are congruent. I would love for you to do this proof. So I did the first column for you, and I'm going to talk through it with you, but your job is to write the reasons in our second column. So you are given that this and that are parallel. When we see parallel lines, we immediately need to think about alternate interior angles or corresponding angles or alternate exterior angles being congruent. Angle Q and T, I'm not given that information, so I have to use logic and reasoning on that. XR bisects QT. So XR is this one, and it bisects that one. We have to be able to use English language conventions here to understand that XR bisects QT, XR cuts this one. This is the one that's cut into congruent parts. So QT is now broken down as QM and TM by the definition of bisect. All right? We have an angle QMX, which is this one, and they're saying that it's, whoops, let me mark this other one. They had that one marked. Now they're saying that this one and this one are congruent to each other. And the question is why? Why are those angles congruent to each other? Hopefully you can tell why these angles are congruent, why those angles are congruent, why these segments are congruent, and then you can tell what reason is the case, what is the triangle congruent shortcut for why these triangles are congruent to each other. So think through that, see if you can fill in the blanks. Remember, you don't get points for getting, or you don't lose points for getting them wrong, you just lose points for not finishing it. So give it a shot, try your best, fill in the blank. Even if you know you're wrong or think that you're wrong, try to do it and you might turn out that you're actually right. Hopefully now you understand how to use those shortcuts angle, side, angle, and angle, angle, side, along with our previous shortcuts side, 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 and side, angle, side.